At the point when we consider stars, we commonly imagine minuscule, shimmering specks dissipated across the night sky. This is the manner in which we see them from Earth. However, stars such as Betelgeuse stand apart decisively. Betelgeuse, specifically, is so massive that it dwarfs our Sun. By comparison, this star has fascinated scientists for many years. Of late, however, new discoveries surrounding Betelgeuse have raised additional concerns among experts. In this article, we will delve into the latest developments regarding Betelgeuse, including predictions from the James Webb Space Telescope about its eventual end. We'll also examine what these events could mean for our galaxy and life on Earth, with insights from physicist Michio Kaku. Betelgeuse is a genuinely captivating cosmic mystery, a giant star that has enthralled astronomers for ages. The first recorded discovery of Betelgeuse was made by the ancient Greek astronomer Hipparchus. It is so massive that it can be seen clearly with the naked eye, especially during the colder months. If you are an astronomy enthusiast, odds are you're familiar with it. Betelgeuse is the dazzling, reddish-orange star marking the upper left shoulder of the Orion constellation. It is an ancient star and one of the brightest objects visible in the night sky. However, its brightness is not constant and fluctuates over time. This changing luminosity is one of the star's most captivating qualities, yet it is by no means its only remarkable characteristic. Most stars visible to the naked eye are located at enormous distances from Earth. The closest star to us, Proxima Centauri, lies 4.2 light-years away. To put this distance into perspective, a light-year represents the distance light travels in 1 year at a speed of around 186,000 miles per second. In 1 year, light can travel billions of miles. Hence, when we say Proxima Centauri is 4.2 light-years away, we are suggesting it is billions of miles from Earth. On the other hand, Betelgeuse is significantly farther away, located approximately 600 light-years from Earth. Reaching Betelgeuse at the speed of light would take a full 600 years. Unfortunately, humanity is still far from being able to travel at light speed, even with the fastest spacecraft available. Despite this enormous distance, Betelgeuse shines brightly in our night sky. You might wonder how such a distant star can still be so luminous. The answer lies in Betelgeuse's extraordinary size and extreme brightness. Betelgeuse is approximately 764 times the size of our Sun, with a radius believed to be several times that of the Sun itself. When observed through advanced telescopes, Betelgeuse appears more like a disk than the typical point of light seen with most stars. This phenomenon is thought to result from the intense reactions occurring in its outer layers. In terms of mass, Betelgeuse weighs between 12 and 20 times the mass of the Sun. A single solar mass is equivalent to about kilograms. However, astronomers cannot measure Betelgeuse's mass precisely due to the lack of orbiting planets or objects that would allow direct measurement from Earth. The fact that Betelgeuse is significantly more massive than the Sun makes it stand out. Its brightness varies between a magnitude of +0 and +1.6, meaning it can be thousands of times brighter than the Sun, earning it the classification of a red giant. However, its luminosity is not stable. It fluctuates due to internal pulsations within the star. When Betelgeuse expands, it becomes brighter, and when it contracts, it dims. These cycles can last from 10 to 100 days or even longer. Another fascinating aspect of Betelgeuse is the presence of dark magnetic spots on its surface. These are regions where the magnetic field is much stronger than usual, preventing hot gases from flowing to the surface and causing those areas to cool. Betelgeuse has far more of these magnetic spots compared to our Sun, which is why it appears cooler despite its much larger size and brightness. Although our Sun also has dark magnetic spots, Betelgeuse's are far larger and more numerous. Some of these spots can be twice as large as Earth. In fact, Betelgeuse has a magnetic field 20 times more powerful than the Sun's. This magnetic field creates swirling or arc-like patterns on the star's surface when viewed through telescopes. The surface temperature of Betelgeuse is approximately 3,500 Kelvin, contributing to its faint red glow. Interestingly, Betelgeuse wasn't always a red star. About 1 million years ago, it had a yellowish hue, similar to our Sun. Over time, it shifted to an orange and eventually red color. Around 40,000 years ago, Betelgeuse began its transition into the red star we observe today. This has led scientists to believe that Betelgeuse is now aging. Betelgeuse emits up to 100,000 times more energy than the Sun. If it were closer to Earth, it would outshine our Sun. If positioned much nearer, it could even be visible during the day due to its immense size. If Betelgeuse replaced our Sun, it would engulf Earth and the nearby planets. Even if Betelgeuse emitted the same energy as the Sun, it would still radiate far more power, making it even more imposing. Despite being located 600 light-years away, Betelgeuse remains visible to the naked eye. This is a remarkable feat by contrast. Our Sun is only 8.3 light-minutes away, making it much brighter due to its proximity. Betelgeuse ranks among the largest stars known to us, with a size roughly 764 times that of the Sun. If placed at the center of our solar system, it would easily encompass the orbit of Jupiter. This colossal size makes Betelgeuse appear as a disk when seen through powerful telescopes, unlike most other stars, which appear as small dots of light. While Betelgeuse may not be the most massive star in the universe, its mass is estimated to be between 12 and 20 times that of the Sun, depending on varying estimates. One of the most intriguing aspects of Betelgeuse is its variability in brightness. Unlike our Sun, which remains relatively constant, Betelgeuse experiences irregular fluctuations in luminosity. At its brightest, it is thousands of times brighter than the Sun, but during its dimming periods, its brightness can decrease significantly. These variations have fascinated astronomers for centuries and provide valuable insights into the star's life cycle and characteristics. The surface temperature of Betelgeuse, at around 3,500 Kelvin, is relatively low for a star of its size, giving it its characteristic reddish-orange hue. As a red giant approaching the end of its life, Betelgeuse has exhausted its hydrogen fuel and is now fusing heavier elements. This fusion process generates energy and causes the star to expand. Its surface is also marked by dark magnetic spots, far larger than those on the Sun, which restrict the flow of hot gases to the surface, leading to cooler regions. Betelgeuse has long been studied by astronomers, with various cultures, including the Greeks, Egyptians, and Chinese, documenting its position and brightness. In Arabic astronomy, it is referred to as Yad al-Jawza, meaning the hand of the giant. Recently, Betelgeuse has gained even more attention due to a series of dimming events that began in late 2019 and continued through mid-2021. During these events, the star's brightness dropped to unprecedented levels, sparking speculation that Betelgeuse might be nearing the end of its life and potentially going supernova. A supernova is an explosive event that occurs when a massive star runs out of fuel and collapses under its gravity. A supernova, it would become one of the brightest objects in the sky, visible even during the day. The possibility of Betelgeuse going supernova has captured the imagination of both scientists and the public. Astronomers continue to monitor the star using advanced telescopes and space-based observatories to better understand its behavior and evolution. Betelgeuse's status as a red supergiant offers critical insights into the later stages of stellar evolution. These stages involve the fusion of heavier elements in the star's core and the subsequent dispersal of these elements into the interstellar medium. Studying Betelgeuse helps astronomers understand the complex processes that shape the universe. When we look up at the night sky, we often see stars as small, distant points of light. However, stars like Betelgeuse, located in the Orion constellation, are much more than that. They are some of the largest and most iconic stars visible from Earth, and their stories are filled with cosmic drama. Positioned around 600 light-years from Earth, Betelgeuse is a red supergiant star in the final stages of its life cycle. Its diameter is estimated to be 764 times greater than that of the Sun. If placed at the center of our solar system, it would extend beyond the orbit of Jupiter, dwarfing our Sun. Despite its massive size, Betelgeuse's brightness varies significantly. At its peak, it is over 100,000 times more luminous than the Sun, but it can also dim considerably. The dimming observed in late 2019 sparked widespread interest in whether Betelgeuse might be preparing to explode into a supernova. Although Betelgeuse's behavior has fascinated astronomers for decades, the dimming in 2019 and 2020 was unprecedented, making it one of the dimmest stars in the Orion constellation. Some believed this dimming could signal an imminent supernova, but recent studies suggest it was more likely caused by a dust cloud forming around the star. Betelgeuse regularly ejects material, and occasionally, this material clumps together to form dust clouds that obscure the star, reducing its brightness. While the dimming cloud temporarily lowered Betelgeuse's brightness, the star itself remains active, and there is no direct evidence to suggest it is on the verge of exploding. To fully understand Betelgeuse's significance, we must delve into its life cycle. Like all stars, Betelgeuse began its life in a molecular cloud of gas and dust. For most of its life, it fused hydrogen into helium, much like our Sun does now. However, as Betelgeuse ran out of hydrogen, it began fusing heavier elements such as helium, carbon, and oxygen. This process releases immense energy and causes the star to expand into its current red supergiant phase. Betelgeuse's eventual fate is to collapse under its own gravity and explode as a supernova. When this happens, it will leave behind a neutron star or possibly a black hole, depending on the remaining mass. The explosion will eject massive amounts of material into space, seeding the surrounding interstellar medium with heavy elements like carbon, oxygen, and iron. These elements are critical for the formation of planets and even life itself. If Betelgeuse were to go supernova, the event would have profound implications for astronomers and humanity. For several weeks, the supernova would outshine every other star in the sky, becoming as bright as the moon or even brighter. It would be visible during the day and would provide astronomers with an unparalleled opportunity to study the death of a massive star in real time. The explosion would release a massive amount of energy, but at 600 light-years away, Earth would be safe from any harmful effects. Betelgeuse's story is a reminder of the incredible scale and complexity of the universe. As we study this massive star, we gain a deeper understanding of the life cycles of stars, the processes that shape galaxies, and the origins of the elements that make up everything around us, including ourselves. Betelgeuse is not just a star, it is a key to unlocking the secrets of the cosmos. Betelgeuse's impending fate as a potential supernova has captivated astronomers and the general public alike, as it represents a rare opportunity to observe such a monumental event in cosmic history. Massive stars like Betelgeuse spend their lives in a constant battle between gravity and outward pressure from nuclear fusion. Once the star's core can no longer sustain fusion, gravity wins, and the core collapses in a fraction of a second. This collapse triggers the explosive release of energy we call a supernova. If Betelgeuse goes supernova, the event will significantly impact our understanding of stellar evolution. Astronomers would use ground-based and space-based observatories to capture every stage of the explosion. The light curve, brightness over time, and spectral data would provide invaluable insights into the physics of supernovae, the chemical elements produced, and how these elements are dispersed into space. Observing Betelgeuse in its final moments would also help refine models of how massive stars end their lives. Beyond its scientific importance, a Betelgeuse supernova would be a spectacle unlike any seen in recorded human history. For weeks or months, the explosion would dominate the night sky, illuminating it with a light far brighter than that of the moon. Ancient records suggest humanity has witnessed supernovae before, such as the one observed in 1054 CE, which created the Crab Nebula, but none in recent history have occurred so close or with a star as iconic as Betelgeuse. While Betelgeuse's supernova would not pose any direct threat to Earth due to its distance of 600 light-years, the event would generate intense interest in how such explosions influence their surroundings. Supernovae release vast amounts of radiation, including neutrinos and gamma rays, which interact with the interstellar medium. These interactions can trigger the formation of new stars by compressing nearby gas clouds or enriching star-forming regions with heavy elements necessary for planetary systems and life. Betelgeuse is also part of a broader narrative about the life and death of stars. Stars like it are the universe's forges, creating elements like carbon, oxygen, and iron through nuclear fusion and supernova explosions. The calcium in your bones, the oxygen you breathe, and the iron in your blood all originated from stars like Betelgeuse that lived and died billions of years ago. This connection underscores the idea that we are, quite literally, made of stardust. Although Betelgeuse's timeline to supernova is uncertain, astronomers estimate it could happen within the next 100,000 years, a blink of an eye in cosmic terms. The dimming events of 2019 to 2020 sparked speculation that the star's demise was imminent, but subsequent studies revealed that the changes were likely caused by a massive dust cloud and surface activity rather than an imminent collapse. Nevertheless, Betelgeuse remains under close observation, with instruments like the James Webb Space Telescope, JWST, and Hubble Space Telescope monitoring its behavior in unprecedented detail. As we await Betelgeuse's eventual fate, its study continues to inspire wonder and scientific discovery. Whether it explodes tomorrow or millennia from now, Betelgeuse serves as a reminder of the dynamic, ever-changing nature of the cosmos. Its story is not just about a single star but about the universe's grand cycles of birth, death, and rebirth, connecting everything from the smallest atoms to the largest galaxies. In the end, Betelgeuse.